Okay, so welcome back. Sorry about that, I had to go take care of something real quick. Okay, so let's finish this up. Okay, so where were we? Okay, so here we have this so far, right? So we've got f of x2, we've got f of x0, and then we've got this in here. So notice that this is of the form x squared plus xy, or 2xy plus y squared, which is equal to x plus y squared. It's a perfect square. Okay, so we've got a x squared plus 2. Let's just make sure I'm not missing anything here. Oh, yes I am. There should be a 2a here. 2a. Yeah, 2a. Okay, yeah, now that's right. So ax2 squared plus 2ax x2 times x0, and then a x0 squared. Okay? So this is going to be equal to, we're going to pull the a out, so this is going to be equal to delta x over 3 times f of x2 plus f of x0. This I'm going to pull the a out, so this will be a, excuse me. Then the rest of it is going to be what? It's going to be x2 plus x0 quantity squared plus, I'm going to pull the 2b out, so this is going to be 2b times x2 plus x0 plus 4c. Okay, so now here's where the midpoint formula comes in. Remember I said that x1 is x2 plus x0 divided by 2. Okay, which means that x2 plus x0 is 2 times x1. So now we're going to substitute in 2 times x1. So this is going to be delta x divided by 3. And so I get f of x2 plus f of x0 plus a times 2x1 squared plus 2b times 2x1 plus 4c. And now, this is going to give me a 4x1 squared. So this is going to equal delta x. Let me erase this. And so we're going to have f of x2 plus f of x0 plus, this is going to become 4a x1 squared plus 4b x1 plus 4c, and this will be 4 times f of x1. Now, if we do this, so now let's rearrange this. This will be delta x over 3, and we get what? F of x0 plus 4 times f of x1 plus f of x2. Okay, now, so far so good. Now, I'm not going to do the whole thing over, but similarly, what if I took f of x2, f of x, or excuse me, what if I took x2, x3, and x4? What if I took the next two pairs? Excuse me. So what would I get? So if I went ahead and did x2, x3, and x4, and did the same derivation, I would get a similar result. Okay, so let's put this together then. If I did this for x0, x1, and x2, and then did the same thing for x2, x3, x4, I'd get two areas, right? So this represents the area, the approximate area under x0 to x2, okay? And if I did the similar thing, I would get a similar result for that. So then what I would do is I would get the integral from x 0 to x2 of f of x is approximately what? Delta x over 3 times f of x0 plus 4 times f of x1 plus f of x2, right? And then the integral from x2 to what? x4 of f of x is approximately then would be delta x over 3 times, oops, f of x2 plus 4 times f of x3 plus f of x4, right? So if we take the approximate area here from this interval, x0 to x2, and then take the approximate area under the curve by using x2 to x4, right? And we're going to add those, right? So we're going to add those areas. So the integral from x0 to x4 then of f of x would be approximated by taking this plus this. Well, if I factor out the delta x over 3, what do I get? I get f of x0 plus 4 f of x1 plus, now I've got this one plus this one, so that'll give me 2 f of x2, and then I've got 4, oops, 4 times f of x3 plus f of x4. And so now you start to see the pattern evolve, the pattern come out. So we start with this point here, the first point, and then we go 4. So 1, 4, 2, 4, and then back to 1. So it has this alternating pattern here. Okay? So it starts with 1 and then 4, and then it goes, right? And then it has alternating between 2 and 4, and then it ends on a 4, 1. So it begins with 1, 4, and ends with 4, 1. So in between, it's got this, this pattern 4, 2, 4, 2, or 2, 4, 2, 4, however you want to look at it. And that's it. That's the pattern. Now, so in the next video, I'm going to introduce the theorem, which will introduce the general form of this, which is pretty much this right here. Okay. Have a great day.